this video, we'll talk about using integers and rational numbers. First, the vocabulary. Whole numbers. They refer to numbers such as 0, 1, 2, and 3. Integers, on the other hand, are the numbers -3, -2, -1, 0, 1, 2, and 3. So they can be positive numbers or negative numbers. Rational numbers are a number a over b, where a and b are integers and b does not equal 0. Opposites are two numbers that are the same distance from 0 on a number line, but are opposite sides of 0. Absolute value is a distance between a and a number and 0 on a number line, where a is a number. The symbol absolute value a represents the absolute value of a. Conditional statement has a hypothesis and a conclusion, often written as an if-then statement. So there are several types of numbers. There's imaginary numbers, which are typically studied in Algebra 2. There's rational numbers, which include fractions, decimals, mixed numbers. We have our integers, which include our negative numbers, and our whole numbers, and our natural numbers, which are counting numbers like 1, 2, and 3. And then we have some irrational numbers, which include numbers like pi and square root of 2. Example 1. Graph -4 and -7 on a number line and tell which number is greater. So we have a number line here, so we'll just make plots and we'll make some numbers on it. So we'll start with -9, -8, -7, -6, -5, -4, -3, -2, -1, 0, and 1. So we're going to put a dot above -4, a dot above -7. So we've graphed them. And we'll just write it as an inequality. -4 is greater than -7. In words, -4 is greater than -7. And we are done example 1. Example 2. Tell whether each of the following numbers is a whole number, an integer, or a rational number. Using the numbers 7, 0.9, -5 and 9/10, and -75. So we have 7. Is it a whole number? Yes. Is it an integer? Yes. Positive and negative numbers are integers. Is it a rational number? Yes, we can also say this is a rational number because 7 can also be written as 7 over 1. 0.9, is it a whole number? No. Is it an integer? No, but it is a rational number. -5 and 9/10. Is it a whole number? No. Is it an integer? No. Is it a rational number? Yes, because it does fall in the form a over b. I can convert this, in other words, meaning I can convert this -5 and 9/10 into the form a over b. If I wanted to, I can just convert this into an improper fraction. As 10 times -5 would be -50 plus 9. So that would be -59 over 10. So because I can write that in the form a over b, it is a rational number. Last one, -75. Is it a whole number? No, because it's not a 0, 1, 2, or 3. Is it an integer? Yes. Is it a rational number? Yes. And that completes our table of telling whether a number is a rational number, an integer, or a whole number for a few examples. Example 3. A star's color index is a measure of the temperature of the star. The greater the color index, the cooler the star. Order the stars in the table from hottest to coldest. So we have the star Regal with a color index of negative 0.03, RNA with a color index of 0.21, the Nebula with a color index of 0.09, and Shala with a color index of negative 0.22. Let's make a number line. So we'll start with negative 0.30. Next we'll skip one. This will represent negative 0.20. Negative 0.30, negative 0.2. Next will be negative 0.1. We have 0, then we have 0.1, and then 0.2, and so on. So first, negative 0.3, it would fall between 0 and 1. So here's Regal. We'll put an R above it. Negative 0.21 would be between 0.2, so we'll put an A above that. Then we have the Nebula. That's between 0 and 0.1, a little bit closer to 0.1. We'll put a D above that. And Shala will be between negative 0.2 and 0.3. And we'll put an S above that. It's asked us to order the car index, the cooler star, so it's asked us to order them. So it will be in order, it would be Shala, Regal, the Nebula, just by looking at our number line. And then last but not least, RNeb as our coolest star. And we are done example 3. Example 4. Find the opposite of the following numbers if A equals negative 6/5. So opposite, when we say opposite, we just write it as such. We put a negative and then we put negative 6/5. This means just find the opposite, so we just change the sign. So this becomes positive 6/5 and we're done. If A equals 0.65, so we just put a negative in front to indicate the opposite. Put 0.65 inside the parentheses, and we just change the sign, so this becomes negative 0.65, and we are done example 4. Absolute value. It measures distance from 0. For example, the absolute value of negative 3 equals 3 because it's 3 units from 0. The absolute value of 4 is positive 4 because it's 4 units from 0. Distance is never negative, so absolute values are never negative. Example 1, 5. For part A, if A equals negative 3/4, find the absolute value. So what we do is just make our absolute value symbol. It's just negative 3/4. Put that in the middle. And absolute value negative 3/4 is just positive 3/4 because remember, distance can never be negative. Part B, if A equals 35, so just make our absolute value symbols, put 35 in the middle. And the absolute value of 35 is just positive 35 because again, absolute value cannot be negative. Trick question, if A equals 0, we say absolute value is 0. Is the distance from 0 is 0, so absolute value of 0 is 0, and we are done example 5. Example 6. Identify the hypothesis and the conclusion in this statement. If a number is a rational number, the number is an integer. Tell whether the statement is true or false. If it is false, give a counterexample, or in other words, a situation where it is false. First, let's identify the hypothesis. The hypothesis is always the if part of an if-then statement. So that's just if a number is a rational number, that's your hypothesis. The conclusion would be just the then part. And that's the number is an integer. So this is a false statement. And an easy counterexample, if a number is a rational number, the number is an integer. So if we say the number 1/2, 1/2 is not an integer. 1/2 is a rational number, but it's not an integer. I can use any number of fractions or decimals. For example, I could also say 1/3, which is also not an integer. Negative 1/4 is also not an integer. So any fraction is not an integer. And there's 3 examples I just gave. I hope that helps you understand the idea of integers and rational numbers.